Welcome back everybody. Today in this video I'm going to be covering how to get the perfect dimensions out of your 3D printer. If you have any questions about how the science works and how the 3D printer will use the values that we're changing, I highly recommend this article located at all3dp.com. I'll have a link to it in the description below, but in basics it tells you how a stepper motor runs. The first thing that we need to do is to print off a 20mm calibration cube. You can find an STL file for this on Thingiverse. There's quite a few different designs, and honestly, any of them work. The important thing that matters is when you print this off, if you have a heated bed, let it cool to room temperature. Because if you try and pull off the build plate while it's still hot, there is a slight possibility that you could squish the Z-axis, or one of the axes that we'll be measuring, and that will give us an inaccurate measurement, which will basically end up leading to all of your prints being slightly skewed on one of the directions. Once you have that printed off, we're going to measure each of our directions at least 3 places. I've already printed mine off, and I've already measured, and I've already taken average values. You can see these right here. When I'm taking my measurement, I found that this really changed the dimensions of my prints. As I stick my calipers around each edge of the calibration cube, I make sure that it's just loose enough that I can slide it along the face without the measurement growing any larger. If you just take your calipers and squeeze them onto the cube, you're actually cutting into the cube a bit, and you're going to get a measurement that's smaller than what you're actually putting out on your 3D printer. If you keep doing this, you'll find that your tight tolerance prints are actually going to be coming out glued together. So once we have these averaged values, we're going to run through a fairly simple equation to get our new E-step values that we're going to feed the printer using a command called M92. So in order to find my new X value, we're just going to use this equation right here. Right now, my current printer is set up with its stock settings, which you can find typing in M503, which I did right here, and it spits out a lot of the settings on your printer. And near the top, it says steps per unit, and then M92, X80, Y80, Z800, and then I have an interesting value for my extruder, but that's because I've already calibrated it. And if you're following through the videos that I produced, you won't have a stock value either. So this is where that 80 comes from. As I take this 80mm from M503, and I'm going to multiply it by the dimension of the cube that it was supposed to be, which in this case was 20. Then I'm going to divide it by my measured value. So we just come over here to a calculator, 80 times 20 divided by 19.93. Honestly, these values for me are really close, so I'm not quite for sure if I'm going to actually change them, but for the demonstration of the video, I'll show you how to do it. So I'm just going to take a look at this value, 80.28, and type that in. Then we're going to do the same for the y-axis. 80 times 20 divided by 20.01. It'll be a very similar value, and I just come right over here and type in 79.96. I'm not for sure how the firmware on 3D printers really likes extra digits, so in order to know how many digits to plug in, I just always reference the M503, and if it only has 4 or 3, I plug in 4 or 3 right back to it. Then for the z-axis, this one's a bit interesting, and I feel that a lot of people can overlook a potential issue. This issue is your initial layer height. In an ideal world, you'll always have your nozzle set to the perfect amount, so that way when it's printing off the first layer, it's that exact height. I find that even though I have my initial layer height set in Cura to 0.2 millimeters, I get the best results out of it when it's set to 0.15 millimeters on the actual print. So my layer height is squished a little bit on the first layer, and when I measure my calibration cubes, I should expect my overall value to be down by 0.05 millimeters because of the error in the initial layer. So that is why I have measured the skirt thickness in at least 4 places and averaged it out. Now, using this averaged value, I'm going to subtract it from my overall z value, and that's what I'm going to use for this measured z value part that goes into the bottom of this z-step equation. It's pretty simple. I just type in 20.13 minus 0.2075, and that gives us an answer of 19.92. To get this correct dimension here in the top, we're going to subtract the initial layer height from the cube. Just in this case, we're not using the measured values, we're using the design values. If you can't figure out what your initial layer height is set to, it's typically defaulted to the overall layer height of your print, which is usually around 0.2 for most beginning 3D printers. So to get the design height, we just come over here, do 20 minus 0.2 in my case, and is likely the case for everybody watching this video, and we get 19.8. To find the new E-step value for the Z-axis, I just take my current E-steps, which is 800, times by 19.8, which is the design value, and then I'm going to divide by the measured value, which was 19.92. And that gives me a new z-axis E-step value of 795.18. Now all we have to do is tell the printer to use these new values. I'm just going to copy and paste, but it's perfectly fine to type in the new values right here. As long as it's M92 space, whatever the axis is, and the new value. For me, I've just pasted it in. I'm going to hit send, and then I'm going to type M500 to save it to the EEPROM, so that way when you power cycle the printer it doesn't lose these changes. And then I'm going to type M503 again to see if it actually took these changes, just as a visual confirmation. Let me reload this page, so that way we can get this new status message. Alright, there we go. We can see that my Ender 5 Plus has accepted the new E-step values. Now what I'm going to do is print off the same G-code file for the calibration cube, take my measurements again, calculate new E-step units, and send them right back to the printer. I highly recommend doing this at least twice, if not 3 times. The more times you do it, the more accurate your prints will be. Good luck and enjoy your 3D printing.